Hey, let's do area between curves. To day three. All right, so for each question, the following carefully shaded region the boundaries are specified. Write the integral expression to determine the area of the shaded region. Be careful here. Recall the area is never negative. Okay. Evaluate the integral without a calculator if possible. Otherwise, your calculator. Otherwise, you use your calculator to find the decimal population with accuracy. So we are going to find the area of the region bounded by the natural log of x plus 1 and the x-axis on the interval from 0 to 1.5. So, first step, draw this out. We have our function here. We have our x-axis. We're going from 0 to 1.5. We're about here. So we want to find that area right here. Okay. So, finding area. How do we find area of most of shapes? Like if this is a rectangle, how do you find area of a rectangle? Base times height or length times width. Okay. The height of this function is the y value at each point. Okay. The base of the function is the change in your x values. So your dx, your delta x, your base, your fx is your height. So when we do the integral from 0 to 1.5 of the natural log of x plus 1, right, dx, right, this right here is the height, right, dx, right, delta x, the fact that we're going to do this using the bounds. So the bounds along with delta x of this right here would be your width. Okay. Now, we don't have to do this by hand. We can just go and put this in a calculator. So what is this in a calculator? My calculator should be able to do this on the step. So from 0 to 1.5 of the natural log of x plus 1. So go to, say, 3 decimal places instead. So 0.791. So approximately 0.791. Now, if I wanted the region bounded by the same function, but my interval that I'm using changes from negative 0.5 here to 1.5 here. Okay. Now, we are finding the area bounded by these two functions. And the two functions are basically y equals 0, the x-axis, and y equals natural log of x plus 1. At some point, our area for these, well, anytime, if this was just find the integral of that area, anything below the x-axis would be considered a negative value. In this case, what I want is the area between two curves. Or between two, yeah, so I'm doing total area. So if I have two functions in this case I have the x-axis, which is y equals 0, and the natural log of x plus 1, at some point, one function will be greater than the other. Okay, in the first graph we had, my natural log of x plus 1 was the greater function. It was above the x-axis. Okay, but here, there's a point where the x-axis is above the function. In those cases, we have to switch things around. Okay. Now, because I have a function of just y equals 0, it's pretty simple to do this. Right? So for that first function, technically, when I do the area between the curve, I'm going to do my upper function minus my lower function. But why didn't I do that for that first question? Why didn't I subtract my lower function? What was the lower function? The x-axis. What's the equation for the x-axis? What happens when I subtract 0? Nothing happens. There's no need to put minus 0 on there. That's why it's not included in that first one. But the second one, since I need to reverse the order, I mean my upper function is now 0. It's going to be the integral from 0 minus my lower function. Well, the integral from -5 to 0 of 0 minus natural log of x equals 1. So what I'm trying to say is this. Right here is where they change position, where y equals 0 is greater than y equals the natural log of x plus 1. So for this first integral, we're taking from -0.5 to 0, where it changes, of 0 minus the natural log of x plus 1. Then I'm going to add the integral from 0 to 1.5 of the natural log of x plus 1 minus 0. So, when you have two functions, when you're trying to find the area between two functions, you have to know when is one function greater than the other. If one function is greater than the other on the entirety of it, then it's just the integral of the whatever bounds you have, the greater function minus the lower function. But if they have a cross, you have to create two integrals. One where the first function is higher, and the second where the second function is higher. So here we have two integrals. The first integral, 0, is higher than the natural log of x plus 1. On the second integral, natural log of x plus 1 is higher than 0. And that's how we find the area between two curves. Do we already have this right here? Yeah, we just have it. 0.791. We just need to plug this in our calculator. So -0.5 to 0. Again, 0 minus the natural log of x plus 1 is just negative natural log of x plus 1. So I get 1.53, sorry, 0.153. I'm going to add those together, so plus so if I add them together, yeah, they still add together to 0.944. Because if I didn't do that, let's say we'll see what happens if I left it as just integral from -0.5 -0.5 to 1.5 of the natural log of x plus 1. Did I get 0.944? No, because what this is doing is net. It's not doing net area. Okay, this is assuming that I'm just looking at where is my function positive, where's my function negative. Right? This doesn't account for the fact that I have two curves. Okay. If I have two curves, I do need to know where one curve is greater than the other because on every one of these, my areas are always going to be positive. Okay. So in order to have a positive area, I need to have the greater function minus the lesser function. So whatever function has the higher y value at the time goes first, minus whatever function has the lower y value. And at this point, they switch places. They switch places at 0. So my first function keeps this positive. The second function keeps that positive. So, all right. So here we have a different function. We do have x equals 0. Line right here. And we have y equals 1 here. And then this function. So I want to find this area right here. Now, what I don't have is the balance, do I? So what do I need to do? I know 0 is one of my values. I'm going to integrate from 0 to something. I need to find where natural log of x plus 1 is equal to 1. Right? Where's the natural log of 1 equal to? Where's the natural log equal to 1, by the way? 1. E. Right. So we need to find where x plus 1 is equal to e, which means x is equal to what? E minus 1. So I'm going to from 0 to e minus 1. Now, which function is greater? What's the top function? Y equals 1. That's my top function. My lower function is what? Natural log of x plus 1. X equals 0 just gives me my first value. So I'm going to do my top function, 1, minus my bottom function, natural log of x plus 1, dx. And this is really it. It's how you find the area between two curves. Okay. So now there's a second way to do this, and I'll show you that in a second, another way. Let's plug this in our calculator. We have the natural log of 0 to of 1 minus the natural log of x plus 1. We get about 0.718. Now, the other, we're still doing the same concept here, but instead of doing this in terms of x, we can do this in terms of y. Why would I want this in terms of y? I already have the balance. The balance is 0 to 1. Right? Now, you kind of have to flip this sideways. Right? I put this in terms of y, that means I'm looking at making that rhyming sum like this, right? Limit is they go from infinity. Those are my rhyming sums, which means I need my function in terms of what? In terms of y. So I take y equals the net log of x plus 1. How do I get x by itself? So x plus 1 is equal to e to the y. Subtract, can I do that? Subtract 1. Subtract 1, so x is equal to e to the y minus 1. So that's my new function. And the nice thing is, I don't have to worry about the greater than function because my function is the bigger function. That's minus 0 in this case because y goes from 0 to 1. So it's just e to the y dy. Now, can you put that in your calculator? You just change x and y. It's okay to do e to the x dx. So when you put this in, you can do 9. Yeah. And 9. So from 0 to 1, because it's the same concept of second e to the x minus 10 dx. Guess what we get? approximately 0.718. So there are some cases in which it is easier to put your function in terms of y to the best. Because I didn't have to find the balance in this case. Now, it's hard to find the balance? No. It was hard to think about finding the balance because most people will probably just go to the calculator and see where the intersect right decimal. Which is what we did yesterday when we had to find arc length. Okay, so yeah, it still worked. I mean, if we did plug that in the calculator and plug in, it's probably still work. Okay, if we went far enough. But if you had to, if this was like a no calculator question, well, I don't know how you do this without a calculator. So. Page. Any questions on that first page? As hard as it's really not that bad. It really isn't. Okay, it's not that bad. Again, for all these, we're going to have we got to determine, right? Looking at what area we're trying to find, right? Which function is greater than the other. So for all of this, it's going to be all of these integral a to b f of x, g of x, f of x is greater than g of x. That's what graphing helps. Yeah, so all these you're going to want to graph these.
Just which one of those are.
That's it.
That makes sense.
Yeah, I mean, what's great? Yeah, which one's higher up in the graph? That's it. Which one has the higher y? So physically looking at the graph, and all these will be able to graph. Okay. So here we have the region bound, but this is a different interval. Okay, so this is a different interval. So we are going to be taking that same graph that was like that. Now we're bounding this from 0 to 2.5. So 1, 2, 3, so here, right? And y equals 1. Now, y equals this. Okay. Y equals 1 until about what we said this was e minus 1, or yeah, e minus 1. Right here. Okay. So this is y equals 1. That's my, we'll say this is f of x. Okay. This is the natural log of x plus 1. That's my g of x. So where is my f of x greater than g of x? From 0, so where? E minus 1. So I'm going to do f of x, which is 1. This is 1 minus the natural log of x plus 1, right? Yes. We can make this g of x. It really makes no difference.
So I thought we were making one of them.
Yeah, they're both terms of y. F of x, g of x, they all mean. It's just a way to differentiate the function.
Yeah.
So in this case, after e minus 1, so after e minus 1 until the end of the x values, the end of x values is 2.5, my g of x, my natural log of x plus 1 is now greater than 1. That's so this again, this error finding here will y equals 1 is greater than the natural log of x plus 1. And here, the natural log of x plus 1 is greater than what?
So in this one, we don't know one minus the element. So that on this page it's in 0 in the place of 1.
I mean, in two different ways.
No, I mean like on the variable.
The very first problem.
Yeah, on this one.
They gave us a different, they didn't have y equals one in that.
That would like,
That's the second problem, they gave us y equals.
would that be like, the second function or something equals 0?
Yeah, they gave us the balance of the x-axis, which is y equals 0.
Okay. Okay.
So yeah, anytime they do give you one of your bound is the x-axis, that means your function is y equals 0.
Okay.
So we can just put this whole thing in the calculator, they want to do it separately. That, derivative from 0 to -1 of 1 minus the natural log of x plus 1. There you go. Plus that from 1, 2, 5 of the natural log of x plus 1 equals x minus 1. 8.21. Or 0.821. Where's the 1 from again? Oh, we just 1. Yep. So again, like I said, then we have a, here we had, I did fx. I didn't do it backwards. I mean, this should have been g of x, because this one labels fx. So we said g of x equal 1. So wherever f of x is greater than g of x, we put fx first. Fx minus g of x. Wherever g of x is greater than f of x, we have g of x minus f. Right.
Okay. Okay. Understood.
No. E minus 1 is where they switch places. Is the location in which f of x and g of x intersect.
But how did you know?
Because my function is at y equals 1, so I looked at where the natural log of x plus 1 is equal to 1. I know the natural log of e is equal to 1. So I need to make what's inside that function equal to e.
Okay.
You could very well have just plugged in calculator and see what intersect and use the decimal. It should have worked just as fine. That'll be very precise. I can't. All right. So now we have these functions, right? So bounded by x equals negative 0.5 here, and y equals 1. So again, we still know that this right here, the coordinate is e minus 1, and this coordinate here is negative 0.5. So this is e minus 1. That's my x. So those are my bounds from negative 0.5 to e minus 1. In this case, y equals 1 is the greater function everywhere, right? So this is y equals 1, and this is y equals the natural log of x plus 1. So this function is greater than this function everywhere. So it's just going to be 1 minus natural log of x plus 1 dx everywhere. So that gives me math from negative 0.5 to 1 minus the natural plus 1. So approximately 1.372. Now, what do you think method 2 is going to be? Yes, but the function in terms of y. Because what that does to us again is that gives us Well, it doesn't quite help us that much in this case, does it? No. It kind of does though, because we do have an x value here, and what formula is this? We do know this is negative 0.5, so what is the y value here?
Negative.
Natural log of
Huh?
negative 0.5, right? Or what, 0.5? Yeah, natural log of 0.5.
So,
No, it would be just, that's, because you plug negative 0.5 in here, yeah. Natural log of negative 0.5 is a negative value. You plug it in your calculator, you're gonna get it. So my y values go from 1, or for natural log of 0.5 to 1. So I'm going to integrate from natural log of 0.5 to 1. All right. And in this case, this function, if you turn this sideways, this function is greater than my negative 0.5. What was this function in terms of x again? Remember? Take the natural log of x plus 1 equal to y, e to the y, so x plus 1 equals e to the y minus 1 minus 1. So this is e to the y minus 1 minus what? Sorry, I'll wait.
lost.
So this is my greater function. This is my, now in terms of y, this function is x is equal to e to y minus 1. This function is greater than what? X is equal to negative 0.5. So this is greater than negative 0.5. Why? Now you can simplify this, because what happens when you subtract negative 0.5? You get plus 0.5, and what is 1 plus 0.5?
Wait, why did you write ln? E to the I minus one. What's the first thing to e to the y minus 1 plus 0.5 dy?
Was. First one was e to the y.
Was it good?
You gotta go
Yeah, I was just gonna ask if I could have bathroom beforehand.
e to the y minus 1 minus. Again, what was my other function? This is my first function. My other function was x equals negative 0.5. Right? Now again, these functions are in terms of y instead of terms of x. So this is f of y, and this is g of y. In this case, f of y is greater than g of y everywhere. So e to the y minus 1 is greater than negative 0.5 everywhere on my balance. So I'm subtracting a negative 0.5. And what happens when you subtract a negative 0.5? You add 0.5. And negative 1 plus 0.5 is negative 0.5. No, minus negative equals plus. And we get approximately 1.372. We should get the same answer. If you don't get the same answer, then yeah.
Okay. How did you know this is the rest? Like, how did you know they wanted you to stop at where, y equals 1 is no longer the greatest? Like, when they're asking that question.
Figure out.
If I read this, I'd be like, what?
Well, again, I'm showing you that method 1 is your functions in terms of x. Method 2 is your functions in terms of y.
Yeah, no,
Okay.
I understand what we did, I just.
So if you do your function in terms of y, and again, I can't really turn my screen sideways, but if you turn your paper sideways, okay, now we can kind of see that this function is a greater function than this function.
No, I mean, like. Yeah. I don't know, that's this question very well.
Okay. Are you wondering where it got bounds?
Yeah, like, it would literally, if you read question 5, if you read that, like, how would you know to stop? E minus 1, if you didn't have.
Yeah, we wanted to see where these two functions intersect. It's where the two functions intersect. So where natural log of x plus 1 is equal to 1. Where's that? E x plus 1 equals e minus 1 minus 1. That's where we get the e minus 1. We kind of did the same thing over here. No, not really. We didn't need the bounds here. We just saw it. There. Almost up to this now. Nice. This is where we get into the real fun stuff. Okay. Those are nice questions. Number 6. We have the region in the first quadrant. Okay. Bounded by y is equal to 0.5 x squared minus 1, and y equals natural log of x plus 1 and x. So we want, we said specifically what regions? First quadrant. Okay. So I'm taking these two functions. This is that natural log of x plus 1. This is 0.5 x squared minus 1. Okay. But only in the first quadrant. So this area right here. So this is where it gets a little tricky.
So is it just from 0 to the finish line?
If I did just the two functions, okay, if I did this, the integral where they intersect. So let's see where these two intersect. And again, you could find where they intersect. Let's go ahead and just do that. Let's do it the traditional way. Most students would do this. How would you find where those two intersect?
I would.
Yeah.
And then put alternate intersection.
Okay. Go ahead and do that. I grew up using, because again, we have, well, I have up and show you how to use calculator. So I would just graph 5 x squared minus 1 and the natural log of x graph. And then I would go to intersect. I have my intersect right there. Now again, your calculator, you have to go to set and calculate and then look at the intersection, right?
Yeah. And then
So-
we go to the.
I'm sure there's other ways to do this on your calculator. There's a way to calculate the intersections somehow on your calculator. I just have never done it. So whatever gets you, what is the intersection?
It's 1.736.
So 1.736. I'm going to go as far as I can. So 3574 is what I have.
Yeah.
3574. Okay.
So then what the variable just be from 0 to that point?
That's a very good question. Very good question. Let's see what happens if I have an integral from 0 to 1.73574. Now, just between the two curves, right?
Yeah.
Now don't write this down. Okay.
So it's writing.
Yeah. You can, I mean, you're at the first part down. Well, not really. Don't write this down yet. Because what I'm gonna find, if I did my top function, what's my top function, by the way?
It's gonna be the L.
Yeah, natural log of x plus one minus my bottom function, 0.5 of x squared minus one, dx. If I did this, I would be finding the area between those two curves from 0 to this point, which means I would be finding this area as well.
So then we'll be really unfunded.
Yeah. So,
So would you do from 0 to 1 of just ln and then do the from 1 to 1.7 of the ln minus?
absolutely. She's got it, yeah. So instead, this, what I'm gonna do is I'm gonna break this into two parts. One where all my functions are my natural log of x plus one and 0. So from 0 to 1, because that's where those x values are, of just the natural log of x plus 1. Again, you don't have to minus 0 here because what do you get when you minus 0? Nothing. And then I'm going to add the second part of that, which is the interval from 1 to the 1.73574 of the natural log of x plus 1 minus 0.5 x squared minus 1. Yes. So, add, well, 0 to 1, just the natural log of x plus 1 plus, and great, 1 to 1.7357 of the natural log of x 1 minus 0.5 x squared. Let's see how long this will take my, oh, I did one right. Yeah. So that gives me what, 68, yeah, 0.680. We're just gonna put that there, it's fine. Now, method two, what does method two do again? Puts everything in terms of what? Now, why would I want this in this case? Because I would only need one integral. I wouldn't need to separate them. But let's go ahead and solve for y on both these. The first one, if this was 1/2, you would just do 2y is equal to x squared minus 1. Add 1 over. So 2y is equal to, or 2y plus 1 equals x squared, and then square root. Now you would have plus or minus, but in this case, would you have plus or minus? No, what would I have? Plus. Just plus in this case because the other side. So that would be x is equal to the square root of 2y plus 1. Now that's this graph right here. X is equal to the square root of 2y plus 1. And we already know what this one is, right? It was x is equal to e to the y minus 1. Now, you turn this sideways, okay? Which graph is furthest from the y-axis, pretty much? Which graph is above the other? Now,
X equals.
so I'm going to integrate from 0 to 1 in this case, because those are my y values. 0 to 1 of the square root of 2y plus 1 minus e to the y. Well, make sure you put whole thing parentheses. You gotta make sure you scrap whole thing. So that's a whole lot, only one integral. I didn't have to find any weird points for my bound. Just had to put one function in terms of y instead of x. So sometimes method 2 is a bit easier to do. Now the nice thing is both these should give you the same answer, right? So it's square root of 2 plus 1 minus parentheses. To the x minus 1. And we get approximately 0.68. This again, same answer. We should get the same. So, in some cases, putting your functions in terms of y would make finding the integration difficult. Did I have to separate these out? No, just one input. Did I have to find any weird values for my balance? No, I have a balance, 0 to 1. Method 2 in this case was easier. You just had to put the function in terms of y, which again, you guys did it. Algebra 2, right? Or pre-calc. I don't know when you do this in pre-calc, but you should be able to put a function in terms of the other. Any point. Know when you have a positive or a negative. That was on the test, I believe. Know when you had a positive and a negative.
Oh, it's okay today? Go ahead.
That's it for today. So, I'll get homework out.
I need to go out.
Oh,